Okay, in the last podcast of Unit 1, we're going to be talking about density, which is hopefully a little familiar to you. This is just going to cover the top bit of page 18, where we finally learn how to calculate density. And since we've been talking about it before, hopefully you have an idea what it is, but the formal definition for density is a ratio of mass per unit volume. But really, when it comes down to it, density measures how tightly packed matter is, how close or how far away its particles are from one another. And where we started talking about density previously in the unit was when we were talking about intensive and extensive properties. So I'm just going to come right back around and remind you that density is intensive. No matter how much or how little of something you've got, its density will always be the same. And we're going to use that idea here in order to identify some substances. So keep in mind with our solids, liquids, and gases, our solids are the most dense because they have the same amount of particles in a smaller space, closer, tightly packed together. Gases for the same substance generally tend to be the least dense state of matter for the substance. So, what's our formula for density? Definitely need to make sure to get this written down there. D equals m over v. Density is equal to mass divided by volume. And here we have our equation. If you need a reminder that mass will usually be measured in grams. Volume will either be measured in milliliters or centimeters cubed, either one. And that means that density is actually going to be a combination of these two units coming together. So you're going to see the density units either as grams over milliliters or grams over centimeters cubed. It's almost like its own little mini equation there built out of the units of the other substances. Now, you do need to know this equation and be able to rearrange it because we're not always going to be solving for density. So what I have here for you to help you rearrange this is what I call the density triangle, DMV. The M has to be up top in that little area, and if you do that, then anything you're trying to solve for, if you cover it up or kind of cross it out in that triangle, what's left behind is the equation for that thing. So you can see here, density, of course, is M over V. But if I crossed out the V, if I was looking for volume, then I'd have to do mass divided by density. If I was looking to solve for mass, look how D and V are now side by side. That would be density times volume. So this little triangle can help you rearrange the equation in order to be able to use it better instead of having to do complicated algebra with numbers in the equation. Now, I will work out an example in just a minute where we're going to use density in dimensional analysis to solve some problems, but it's only really going to be useful in certain situations, and that situation is not this first problem. Here, anytime it asks us for the density, the simplest way to find density is just to do mass divided by volume. That's the easiest, simplest way to do it. You just got to look at the problems in the numbers in your problem and make sure you're getting them in the right places. This milliliters is our volume and the grams is our mass. So I just need to do this 3682 number divided by 53.4. When I do that, my calculator gives me the answer of 68.951. As always, we need to round that to have the correct sig figs. Since 3 sig figs was the least number that I started with, that means I'm going to be rounding this up to 69.0. That 9 is the last number I want to keep, and the 5 is going to round it up, so it becomes a 0, and the 8 becomes a 9, but still need that 0 there to keep it as 3 sig figs. And the units, of course, grams over milliliters, because that's exactly what I did with these units here. So calculating density shouldn't be that bad. It's the original equation, and you just plug the numbers in. Some people struggle when we're solving for something that's not density, though. Here, it's giving us the density of gold is 19.3 grams per milliliter, and then asks us for the volume if this is our mass. So we would have to rearrange the equation to solve for volume, which isn't too hard if we have that little triangle. Volume is equal to mass over density, and technically all we've got to do is some quick division, just like what we had done in that previous problem. So this would be is 80310, which would be 0.803. This is our volume, so that would be milliliters when it comes down to it. But there is technically, like I said, a way to do this with dimensional analysis. If we do use dimensional analysis here, what it hinges upon is being able to take this density, this 19.3 grams per milliliter, and understand that what that represents is 19.3 grams for every 1 milliliter. Per milliliter means for 1 milliliter. So we basically are pulling apart this density number into an equation that's going to let us convert between grams and milliliters. And now at this point, the 15.5 grams is my given. Since I have grams on top, I'm going to want to put the 19.3 grams part on bottom, 1 milliliter on top. And here, just like when I use the equation, I am going to end up doing 15.5 divided by 19.3, and I am going to get the exact same answer out. It's just a different way of looking at it and problem solving to get here. So we can use density as a conversion factor in a problem, but that's not useful if we're looking for density. If you're looking for density, just plug in your mass and divide by your volume. So here, this is asking us for mass, and it's giving us this volume and our density here. So I could do this with dimensional analysis. Well, you could as well, I'm sure. But if we want to solve for mass without dimensional analysis, we just need to remember to multiply together these two numbers, density times volume, and that gives me an unrounded answer of 59.475, which would round to 59.5 grams. So, one last problem here. This is going to look a little bit different, but it's the same general process. We are trying to figure out the density of a metal, so I'm going to need a mass and a volume, and I see my mass given to me up here. But then it tells me that we put the substance, the metal, into a graduated cylinder, and the water rose from 20 to 41 milliliters. What is the density of the metal? So we need to use this information to find the volume of our shape, but neither of these numbers, none of these numbers, in fact, are the actual volume of the metal. The volume here is going to be equal to the difference between the water level at the beginning and the end, because the difference between the water in the graduated cylinder before and after is that the object was added in there. So the water is taking up all of that space around the object and rising up by the amount of the volume of the object. So here, our volume of this metal object is 21 milliliters. So if I wanted to solve for its density, mass divided by volume means 147 divided by 21, which my calculator tells me is 7. But which I know I need 2 sig figs on, so 7.0 grams per milliliter. And that's that.